We have this cost function. We're supposed to find the representation for the marginal cost. So the marginal cost is telling you how much the cost increases for one increase in units produced. Okay. So in other words, marginal cost is the derivative. And I don't even, it's usually discrete for this. I don't know if it's just for one or if it's just any increase, but either way, the marginal cost is the derivative of the cost function. Okay, so this part students usually don't have trouble with. Derivative of 20,000 is just 0. The derivative of 980x is 980. And the derivative of minus x squared is minus 2x. And then this is for x is less than or equal to, x is greater than or equal to 0, but less than 1,000. Now, at x equals 0, at x equals 1,000, it switches to this function over here, right? The derivative at 1,000, if you plug in 1,000 here, then negative 2,000 minus 980, that's negative 1,020. The derivative on this side is 0. So at exactly x equals 1,000, it's undefined. That's a fine point in calculus. It's never going to break anybody's business. But at exactly x equals 1,000, we don't have a marginal cost function. But for anything greater than 1,000, then the marginal cost is 0 because it's not changing at all. Okay, because the derivative of this is 0. So this is our answer. But again, the big thing to emphasize here is that at exactly x equals 1,000, the derivative on the left and the derivative on the right are not the same. Therefore, it has to be undefined there. Okay, kind of a boring point that students usually miss and get that question wrong because of that. But okay, so we're asked to find the derivative of this function, and they'll actually give you some algebra here. This is a tough one to give to students without something called the chain rule. Look, let's take the derivative like we normally would. This is kind of like your variable, and I say kind of for an important point, okay? This is kind of like your variable. The 6 comes down and multiplies, and then it gets reduced by 1. But there's something called the chain rule in calculus, where if you take a derivative of this, then it's just like the normal power rule, but then you have to chain onto it by multiplying the derivative of the inside function. So the derivative of 2x minus 100, derivative of 2x is 2, and the derivative of 100 is just 0. So that's the derivative of the inside function. So that's called the chain rule, okay? You take a derivative of the outermost function and then multiply by the derivative of the innermost function. That won't come up too much in this section, but I wanted to make sure students knew about it. Okay, so we have our marginal cost function. What's the marginal cost when x equals 51? How much is it costing us roughly per unit at this point? So you just need to plug in 51 in here to finish solving this. All right, so we got 51 times 2 minus 100. Raise that to the 5th power. Multiply that to negative 30. And then multiply by 2. So I got negative 1,920 for our marginal cost when we're on the 51st unit. Okay, so that means they're costing us, well, it's a negative cost. Oh, no, sorry. So that means the cost is decreasing by 1,920. Here, actually, there's a question. Let's do this one next. I meant to block out the right answer, but. Okay, so that's what this next question is saying. When you calculate the derivative of the cost, like this, that's marginal cost, and that's telling you how much of the cost is changing at that moment. So for the derivative of the cost when we're producing 6 units, if that equals negative 5, that means the cost of making these items is going down by 5. As you make more units, you'd expect the cost to continue going down per unit, right? So the cost of producing is decreasing by 5 is the correct answer here. So the derivative of the cost. Remember, derivative is telling you how fast something is changing. So a derivative of cost is telling you how fast your cost is changing. And since it turned out to be a negative 5 for this particular value, that means your cost is changing at a rate of negative 5 per unit. Okay. And then the last one here, I want to do this one. This is also a chain rule type problem. They give you the formula here. This is like your alpha, okay? And then you have to multiply by 200 to the outside. So when you take the derivative, the negative 0.5 is multiplying to the 200 here. So that's negative 100 e to the negative 0.5x. We're going to learn more about this derivative later on in the course with the chain rule, okay? But this is the derivative. Alpha is like negative 0.5, but don't forget you're multiplying the whole thing by 200.